Now, what's a little more interesting is combining two vectors or matrices, two arrays. In this case, it's going to be two row vectors. We're going to add them. So what that means is it adds them element by element. Right? Takes the first element of the one, adds it to the first element of the other. Same with the second and third elements. All right. Which means they have to have the same dimensions. Right? If this had another element, that won't work. I'll get an error message because it's saying, whoops, well, first of all, there was a syntax error. Hang on, let me fix that first. Okay, saying matrix dimensions must agree. Okay, because I'm trying to add them element by element. It's got this extra element. It doesn't know what to do with it. All right, so if you're going to add two vectors, they have to have the same dimensions. And you can do it with column vectors as well. Right, so I've got call vec1, 5 by 1, call vec2, also 5 by 1. So I can add them. Now, here's one that's a little funny. This is a 1 by 5. That's a 5 by 1. I might think because they have the same number of elements, I can add them and I'll get a 5-element vector. It doesn't work that way because even though they have the same number of elements, one's a row, one's a column. So their dimensions are different. So it turns out it will work. It just does what you might not expect. It actually creates a matrix. So what this is doing, it's taking the first row, or taking that row vector, adding the first element of the column vector, and that becomes the first row of the matrix. Then it takes the row vector, adds the second element of the column, and that becomes the second row of the matrix, and so forth. Right, so if you were doing that intentionally, it could be a powerful technique for filling out this matrix, but it's probably not really what you intended to do. If all you wanted to do was that element by element addition, then you probably want to take the transpose of this one. Right, so now they're both rows. Now you can add them. Right, so this is something I mentioned last time. For most of what we do, it doesn't matter if you have rows or columns, but you have to be consistent. Right? If one's a row, you want them both to be rows. All right, here's a quick practice problem. You know the rand function will generate a random number between 0 and 1. Well, if you want a vector of 7 of them, you do 1, 7. Right? So that gives me a 1 by 7 array. In other words, a row vector of 7 numbers, all between 0 and 1. Take a minute and a half and think about how to scale and offset this. So instead of being between 0 and 1, they're between 5 and 10.